Hello, so welcome in the first IoT Studio. This is a new series of video we're launching about Internet of Things, and we will be explaining how to build basically connected things and how to understand protocol and how to make stuff. So in this first edition, we will get a broad overview about protocol and get on a real project. So let's get started. So I have a few questions that I've been asked to answer in this first edition, and still with a big focus on connected things. And of course, a big focus also on XMPP, which is our main area of expertise, even if IoT Studio is not about XMPP. It's much more generic, and it wants to deal with various type of protocol. But this first video will make a deep dive in XMPP in the context of Internet of Things. So the first question is, what are the main classes of protocols for the Internet of Things? There is many protocols, there is a lot of confusion around them, and I would like to just give a broad overview about what is available in terms of protocols for the Internet of Things. Then I will zoom into XMPP and briefly describe the strengths of XMPP in the context of the Internet of Things. I will still zoom further and describe the main extensions that are available in XMPP to build the Internet of Things. And finally, I will explain how to build a real device, a real appliance using XMPP. And we will show and see real code, and this is the project that you can probably reproduce yourself at your office or in your home. So let's get started. So the main question is, what are the main classes of protocol for the Internet of Things? So there are numerous protocols for the Internet of Things, and there is a lot of competing protocols that are acting at different levels and that are filling different needs. So when I look at them, I try to split them into several categories, and I found that there is two main categories. We have infrastructure protocol and we have messaging protocols. So infrastructure protocols are mainly focusing on low-level communication. So for example, you have long-range, low-power protocols that are used to connect things on several kilometers range. And this is the type of protocol you can find with Sigfox, which is a proprietary protocol built by a company called Sigfox, and which is aimed at covering large array of large-scale territories and connect things with their protocol. The drawback is that the very bandwidth is very narrow, and you cannot pass a lot of data using that protocol. And then there is LoRa, which is made by LoRa Alliance, and which is a competing protocol to Sigfox, which is wants to be open and made by several manufacturers, several builders, and that want to compete with Sigfox. And then you have each organization building protocol, wireless protocols that want to build their own long-range, low-power protocol. So you have, for example, LTE-M, which is for mobile, the standard LTE protocol, which is extended for connected devices with SIM card and so on. And then you have the Wi-Fi. The Wi-Fi is quite low range. With Wi-Fi Halo, the Wi-Fi organization want to build a protocol that is longer range, lower consumption protocol, lower power, lower energy protocol, and that want to complement the Wi-Fi protocol. And you have a lot of different protocols that are acting at at kind of same level and are competing in that broad area. So as you see, the scope and is very open, and we don't know yet which will be emerging, which technology will be emerging as a winner. This is a very new topic, and a lot of players are competing around in that domain. And then you have short-range communication, which is basically the protocol that want to cover an office, your home, or factory, but basically this is short-range communication. So this is in range of tens of meters, hundreds of meters, but not more. So, for example, you find Zigbee protocol, which is the most widely used in smart home, building smart homes. You have the NFC protocol, which is even shorter range. You have the Bluetooth protocol, which is well known and used by smartphone computers. You have the Wi-Fi protocol, which is also used by computer and a bit more power hungry than Bluetooth. So again, there is a lot of protocol competing for the short-range communication low level. So this is for the infrastructure protocol. Next is what I call the messaging protocol. And messaging protocol are higher level. They have kind of application level semantic, and they can be transported on various lower level protocols. So that's the idea. And the most typical use cases are sensor metric reporting, which is mainly upstream. So we have data coming from devices to a central point and doing stuff. You used to do stuff, triggers alerts, or gather time series, etc. And you have also use case that are targeting at controlling the devices. So control devices parameters, control behavior, this is mainly downstream, coming from controllers to the various devices. And we have several examples of those protocols. You have, for example, MQTT protocol, which can be used over TCP/IP, or it can be used over UDP as well. So this is a variant, which is MQTT SN, which is mostly targeting at smaller and lower consumption devices. We have XMPP, Extensible Messaging and Presence Protocol, which has a role to play, I believe, in the Internet of Things. We have also Storm Protocol, which is a very basic text protocol for doing pub/sub. And we have also protocols that I've added there that are mostly ad hoc for gathering data. So StatsD, Riemann protocol are all used to gather time series information from sensors, and they can be used as well to build the Internet of Things. And we have many other smaller protocols that can be used for that purpose. So as you see, you have a very broad scope in terms of messaging protocol. We plan to cover a lot of them in the IoT Studio video series. And what you need to know is that even if there is a lot of protocol available, the semantic is always the same. You can broadcast messaging, you can send upstream data, you can send control messages to devices. So the underlying semantic is the same. And it means that an IoT messaging platform will typically speak several protocols and will be bridging and converting between them. It can even act as a gateway between lower level protocol like Zigbee, for example, and convert that protocol to a higher level protocol for broader use over the internet. So Zigbee is not internet, it is short range communication, and it needs to be converted into some sort of internet messaging protocol for things. So as you see, messaging platform tend to be more and more polyglot. They can speak several protocols and act as a bridge. So that's the idea. And what we see also and this is an interesting trend, is that we're seeing a shift from lower level messaging protocol to higher level protocol, because the things get more and more powerful. You have seen that there has been in last November, December, there has been the Raspberry Foundation has released the Raspberry Pi Zero, which is a very small Raspberry Pi and very cheap. It's I think it was sold to £5 or £6 with a magazine. So this is very cheap and very inexpensive devices that can run Linux. So as you see, Internet of Things is getting more and more powerful. Things are getting more and more powerful, running full blown operating system like Linux, and they can do a lot more things. And thus, that's why we are seeing a shift from lower level messaging protocol to things that are more higher level and more developer friendly and more application friendly. So that's the trend we're seeing currently. So in that context, what are the strengths of XMPP for the Internet of Things? And it's obvious that XMPP is very good as a hub, as a platform. This is the central, it is supposed to have as a central server to connect things in the context of federation. So it's not central. It means that you will not have a single XMPP server at a global scale. We'll have several federated platforms that can speak together. But basically, it acts as a hub. The things connect to it and report to the data of the hub or get message control from that hub. And XMPP also is interesting because it supports both sensor reading and reporting and access, controlling the devices. So it's synchronous, it's also asynchronous messaging. So it offers all the semantic I was speaking before previously. It offers all the elements of the messaging semantic, all the components of the rich messaging semantic, and this is why it makes a very good platform for the Internet of Things. However, it has very unique strengths in the context of the IoT protocol landscape, and very unique. So it can natively support identity because the Jabber ID, the G as we call it, is a globally unique identity for things. So you can have a thing that have a Jabber ID at a specific domain, and with that ID, we can reference it and possibly reach it from anywhere in the world. So if I'm on a server A and I want to reach a thing on a domain B, there will be federation entering into play. So I can send a message to my server, my server can send a message, route the message to the server of the device, and pass control XMPP packet. So basically, with that identity, you can build a global, universal things network. The federation is also very important because you can have different manufacturers deploying their own platform for their own things, but still open to federation so that they can cooperate with other platforms. So you can have a things made by one manufacturer connected to the device manufacturer's XMPP server, and it will be able to talk to a things made by another manufacturer connected to another XMPP server, and they will be talking to each other through federation. So that's also a way to make sure that the Internet of Things will actually happen, because I don't believe that a single platform will emerge and handle all the things in the world. There will be different platforms. And that's where XMPP has a very important role to play in that it make it possible to have different platforms speaking together and different devices connected to different platforms interoperate with each other. And the last very important point is delegation. In XMPP, you have an identity that you can trust. You can know that if you trust a specific domain to be a legit domain and not to be a rogue domain, if you trust that domain, you can trust that the user ID behind Jabber ID on that domain is really the user it pretends to be. So with that trust network, you can start building a delegation, and you can start building delegation in the sense of what is called in XMPP IoT corpus of specification, which is called provisioning. You can control your things and allow other user in the XMPP federated network to operate or control or read data from your things. So this is also very, very important and very, very powerful. So that's it for the strengths of the XMPP protocol. Now, what are the building bricks? What are the XMPP extensions that are available for building the Internet of Things? So first, the core of XMPP is already, very, very powerful and allows handling a lot of the features needed by the Internet of Things. So you have authentication, you have federation, you have encryption, you have synchronous or asynchronous messaging, you have delivery offline messages, and so on. So this is already, you have a very good corpus of features, or good set of features that you can use to build the Internet of Things inside XMPP. And on top of that, you have a lot of general purpose extensions that are also very relevant in the Internet of Things topic. So for example, you have PubSub, which is publish and subscribe. You can have things publish data to channel and let subscriber receive update coming from a set of devices or a set of publishing devices. You can, with SSL external authentication with certificate, you can provision things. You can build things, images, that will be able to authenticate and get onto the XMPP network with just a certificate. So if they can show these credentials, they will be able to connect to the network. So this makes it very much easier to deploy a network of things with hundreds of thousands of devices produced. So this is very, very powerful. You have also a way to control things with ad hoc command. You have data forms that allow to interact with things, replying with forms. And if you want to control that thing, you can fill out that forms with parameters and so on. You can have things expose their capabilities, entity capabilities. You can have kind of reliable delivery with message delivery receipt, message carbon, getting a copy of message that you send to your things from an account, from one of your connection to your other connection. So this is a lot of general purpose extensions that are very useful in the context of the Internet of Things. But also in the XMPP Software Foundation, you have an initiative that has been launched around Internet of Things, and that is working on extending the XMPP protocol with the purpose of building the Internet of Things on top of XMPP. So this is still a work in progress, but there is already a lot of specifications that have been produced in that context and in that direction. So for example, you have the XI format, Efficient XML Interchange, which is basically a compression format for XMPP that allows to have much more compact and make XMPP much less variables for small things that are very low on bandwidth. You have a specification to gather data from sensors, or provisioning mostly in that context mean to be able to delegate control of your thing to some of your friends or to some of your partners. You have XEP for controlling things, defining how to send control XMPP packet to things to make the things update itself, do stuff, change the temperatures in your heating, for example. You have XEP defined for discovery of XMPP servers when you bring a thing to a specific network. So you have XEP for concentrators, defining a way to have things that act as a hub for that is smarter than these things that it will manage. So the concentrators will gather data from things that are using a lower level protocol like Zigbee, for example. And of course, in the context of XMPP, some servers bring important features to the table. And ejabberd, for example, by supporting clustering and massive scalability, is a critical component in building the Internet of Things, because it will allow device manufacturers to build platforms able to support millions of things connected on that network. So ejabberd is really a wonderful tool to build the Internet of Things. And this is something you will see more and more in the coming months, use cases and stories around XMPP being used and ejabberd being used for building the Internet of Things. So now we will get into more concrete and on-done experiment. So to demonstrate how you can leverage XMPP to build a real device, a real appliance, I've prepared a demo showing how to plug various things together. So my demo is about building a jukebox whose purpose is to play songs from Soundcloud by sending control instructions over XMPP, and the client the XMPP client will be running on a Raspberry Pi device. So I have used the following technologies to build that platform. I have used the XMPP protocol, so the Raspberry Pi will be a client of an XMPP server. That Raspberry Pi will be connected to ejabberd as a messaging platform. The Raspberry Pi will be running a Go program client, which will be an XMPP client using my own library, the Go XMPP library GOX, that I've been writing specifically for that use case, and that I will be extending in the future a lot. So we're making a lot of new development around that. And yes, finally, the Raspberry Pi is hardware running the Jukebox with a speaker plugged to the analog, the jack sound output. So here is the architecture diagram. So you have a Jukebox which is plugged to an ejabberd server. The users are connected to the ejabberd server as well using a different XMPP account, and then can send XMPP messages or XMPP IQs that are acting as control packets for controlling the Jukebox. As you see, I have represented cloud in that image, meaning that the Jukebox can be in my home and I can control it from a different network. I can connect to the XMPP server over internet. The Jukebox can connect to the XMPP server over internet, and I can control it from anywhere in the world. So this is one of the power of XMPP, is that it's outgoing connection. So the Jukebox will be connecting to the XMPP server and then able to receive control packets using that established connection. But you don't get into the NAT, firewall, L type of issues. You have something very simple. If you have an XMPP server over internet, you can probably control all your things from your office, your home, and control them from anywhere. So this is very, very powerful and interesting. So the client control operation, the first thing I will demonstrate is that my things can be a chatbot, and I can simply send messages. So as you see on the slide, this is simply XMPP chat messages. I am sending a URL from Soundcloud, which is coming from the website. And the Raspberry Pi will receive the message and find from that URL, will find the stream URL from Soundcloud and will play it. So that software, to be able to do that, that software is a SoundCloud client. It has a SoundCloud client ID and is authorized to use the SoundCloud API. And to stop the stream, that's a chat client. You just send stop in the body of the message, and it will stop playing. So that's one way of building, smart things. But we can get further, and we can use IoT-specific XMPP extension, like XMPP control extension, to send IQ packet to be able to pass operation and send very specifically defined, very specific operation to that string. So in that example, I'm showing that the thing is supporting control XMPP packet, and those packets are basically actions. So you can send an action which is play, or action can be stop, and the play action expect another parameter which is a string, which is named URL, and which will be the SoundCloud URL coming from the website, that the things that the jukebox will be playing. So as you see, this is much more advanced, and you can build, this is intended to build generic XMPP controller for your things. And different jukebox, you will be able to control different jukebox using the same type of protocol. Or even different things doing with different capabilities. So to spice the demo a bit, I've made the jukebox able to broadcast user tune. User tune is another specification of XMPP that allows your contact to share the tune they are currently listening. And in that context, the jukebox will be a contact in your own contact list in your XMPP client, and it will be able to update you about the song that is currently playing on the jukebox. So if your client supports displaying user tune played by your contact, then it will be able to display the song currently played by the XMPP jukebox. So I will be giving you a broad, quick overview about the code to show you that this is very, very simple. So here on that page, you see that we have the main function from the XMPP jukebox. So the XMPP jukebox is first initializing an XMPP client, which is a special object, and is asking, is calling a connect XMPP function that will be doing the connection itself. And yes, basically that's it. It will be connecting to XMPP, and then we create a new player which is using MPG123 to play the song in streaming. This is a library that I've been reading as well during the past few days for that specific example. So this is something which is also available on GitHub, and you will be able to get your run on it and play with it as well. So, and then you have the for loop. The for loop is basically iterating on the client receive channel, and it will be, for each channel you can define, for each packet, XMPP packet structures, you receive on that channel, you can decide what you want to do in your program. So if you receive a message, you get to the process message function. Process IQ, you do the same, and we don't expect to do anything with presence at the moment. Then the connect XMPP. Well, this is very simple. You define a structure which is XMPP option structures, which takes the address of the server, the Jabber ID, the password, and several options like packet logger if you want to log everything, all the traffic on the standard output, for example, or the retry parameters if in case there is issues connecting to the XMPP server. Then you create a new client with those options, and then you connect. So that's basically that's it. Then you have the message processing function, which is called process message, and which basically take the packet body, the body of the message, will remove the white leading and trailing white spaces, and if the command is stop, it will stop the player, or if otherwise it will play the URL, so pass the URL command to the Soundcloud players function, and then it will send the user tune. So this is hard coded to the song I like playing while doing my demo, but I didn't at the time to finish the part of the Soundcloud protocol to extract artist and title. But this is hard coding in that example, but this is very easy to make it generic based on what does the Soundcloud API return. Then you have the process IQ, so that this is an alternative way to play songs. So you can either send a message or send an IQ. And when you process IQ, you check this is the case, the first case, is that the IoT control set IQ? And if this is the case, we will be somewhat doing the same. We will be extracting the URL from the control packet, IQ packet. We will be playing that URL. We will be sending the response to that IQ, saying to tell the client that we have received the order and we are currently playing the song, and we will send that user tune PEP, personal event protocol packet as well. So as you see, this is very easy. Process message, process IQ, very, very short code. Send user tune, this is very easy as well. You create a PEP tune structures with artist and title, and you send it in XMPP format on the client. The play SoundCloud URL, this is very easy with my library. You get the song ID, and you format the song stream URL based on that song ID, and then you play that stream on the player. So MPG 123 player. Very, very easy as well. So here is time for the demo. So let me show you how we'll do that. So here, let me close it. So here in that channel for the demo, I have an XMPP server running on my laptop. So here you see that this is an ejabberd server that is accepting connection from client. Here I will try to bring, the camera to show you the thing. So here is the thing. So this is a Raspberry Pi 2. So it's plugged on. So you see the red light, which is it's turned on. You have the power cable, and you have the jack output, analog output, and which is plugged to a speaker, so external speaker. Here you see that we are connected on Wi-Fi. So you have a USB dongle for connecting to the Wi-Fi, and we're using a special SD card which contains our special Linux image, very minimal Linux image that is bringing together all these capabilities, setting up everything to be ready for getting output on the speaker. You have everything set up for taking parameters at boot time to set up the Wi-Fi and so on, so that you can set it up on your own network by just editing a simple file. So this is our powerful ready-made image, and you can expect to hear more about that very soon. Anyway, yes, we're back to the demo. So basically, the very interesting things in being able to, in using Go to build things, especially on Raspberry Pi, is that you can compile everything on your own laptop, on your development environment, no matter what it is, and you can deploy by copying a single file, static linked binary, and it will work out of the box. So this is really, really powerful. So you have seen my code. So you have seen my code, XMPP Jukebox Go code. And by instead of simply doing go build XMPP Jukebox.go, that will build my binary for my local architectures, I will be building for Linux environment on ARM. So basically, instead of building for OS X on Intel processors, I will be building for Linux on ARM processors. So I'm just doing that. Then I will be copying the binary to the Raspberry Pi. So let me just copy that file. So it's probably quite small for a static binary. It's 6 megabytes or something like that. So then if I SSH to that server, to that Raspberry Pi, I can simply start my newly uploaded binary, and you see I'm in debug mode, so you can see all the traffic that is being sent by the Raspberry Pi to talk to my XMPP client, to my XMPP server. So next is to connect with the client to be able to play a song. So let me connect, get online with my account on that server. So I'm now online, and test at localhost is my jukebox. So I can simply tell him to play a song and send the URL, and you probably can hear the music at the moment. It's currently playing. So, and if you see here the little mark, you see that it's currently listening to Radiohead Spectre. So I can just send stop, and now I've stopped the sound, and which is nice, and why I like Psy for demo, because especially on XMPP, is that I can activate a console. So this is a normal chat client, so I can use my jukebox using the chatbot features. But I can also send IoT control XMPP packet directly to my server using my existing connection. So I copy paste that, saying I want to play that Soundcloud URL, and if I transmit it, you see that you can hear that it's now playing, and you see that I received a message, which is a user tune update. And I can, of course, decide to stop it from there, no problem. So yes, that's it for the demo. As you see, this is a very functional jukebox, and this is quite a powerful tool. That's it for today, and for that first IoT Studio session. We will be back soon. So we will be back probably in a month. Maybe there will be an XMPP Academy in between. So thank you very much for your feedback. I will be publishing everything, a link to GitHub, code, and so on ProcessOne blog. So stay tuned. Keep us posted, guys, and see you very soon. Bye. See you.